been using the MDS quite a bit since the previous video. Now it's working. Unfortunately, it became fairly apparent that the interrupt switches weren't working, or when they did work, they were very, very erratic. Went through the logic circuitry on the front panel board, and the normally closed side of all these switches go into an 8 input NAND gate. And it turns out that the IRQ2 switch is busted. If I just demonstrate on the IRQ3 switch, you see we've got a short on that one. On the IRQ2 one, it's completely open circuit. It does work on the other side of the switch though. If I hold it onto there and click it over, so half the switch is working, but the normally closed circuit isn't. And the trouble with it is that gives a logic 0 on the NAND gate, and of course with that the output of the NAND gate can never change, so it stops all the switches working, which is rather inconvenient. I did sort of bodge it earlier just by putting a link across there just to sort of confirm my suspicions. The other problem is as well that a lot of the LEDs, about 3 LEDs don't work. They're either very faded or they're completely dead. I managed to find some replacements. They're quite weird. They're sort of 6mm LEDs, but they're very squat. So I've got those. The switches are actually still available, but only to special order. I've got another switch from the series. It's the same type, but it's got a different rocker on it. So what I'm going to do, I'm going to try and take this switch apart and potentially change the contacts inside it, or the whole rear body, whichever's easiest. So I'm going to get that unsoldered and we'll see what happens. Right, I've got it apart. This is the one one of the new ones I've opened up. You can see where I've just opened up the sides there. This bit was in there originally. There you go. So all I did was I just got a screwdriver in, just hold that up, just pushed it in there, and then opened up the switch. What I've done, I've put the parts from this new switch in the old switch and just closed it up again. And it seems alright. I mean, the weird thing is that the old one, it's going to be difficult to really show you, but I think it's, to be honest, it looks better quality than the new one. Everything's sort of gold plated. It's all clean in there. And the little lever looks in pretty good nick as well, and the little actuator thing is all intact. So I don't know what was wrong with it, but anyway, but that's the switch I've created. Give it a quick test again. Right, so let's just try. Right, that's the normally open side, and if I go around the other side, that's the normally closed side. That's all working. It makes quite a satisfying clicking noise. So I'll put it back in and we'll see what happens. I've put 3 new LEDs in as well, so we'll get it all back together again and see how well it works. Right, I've got the front panel back on the MDS, so we'll do a bit of testing. At the same time, we'll have a sort of minor run through the monitor, just so you've got some idea of how it works. Right, let's get it powered up. So, we're on. Press the boot switch, press reset, and over on the terminal we press spacebar, and release the boot switch. Right, we're now in the monitor. I'll demonstrate the switches and the LEDs are working first. We can do that fairly easily. If we do substitute memory, I'll just use 2000 hex in this case. Press the space, that'll let me edit the first byte. I'll put a disable interrupt in there, which is F3, followed by a halt, which is 76. I'll go back to the monitor prompt and I'll say go 2000, hit return. Right, and you'll notice the halt lights come on, so that's one thing we've tested just with that one little program. Now I'll press each of the interrupt switches. Obviously it won't generate an interrupt because we've disabled the interrupts, but just to demonstrate that they're all actually working. Go. One, that one, and that one. Right, so they all light up now. The light levels are a bit varied. You can see which ones I've replaced. 6, 3 and 1 are a little bit brighter, so I may well change those at some point. Right, as the machine is at the moment, it's completely locked up because we've disabled interrupts, we can't get out. So what we'll have to do again is we'll hit the boot switch, hit reset, all the interrupt lights are cleared, hit space again, release the boot switch, and we're back in the monitor again. One of the interesting aspects of the monitor is it's slightly similar to CPM in that you can assign your physical and logical devices, and in the case of the MDS monitor it appears most of the devices are assigned to the teletype. The setup I've got here at the moment, this large terminal screen, this is the CRT port, and if I just flip over, this is the teletype port. There are some restrictions on the teletype port. For one, it'll only run at 110 baud, which is quite slow by modern standards, and also it's 20 milliamp current loop. So what I've done, I've removed the teletype user and plugged it into another socket on top of the one it's already in, and I've connected directly to the user through this little cable. If you see this little cable I've got here, that's going directly to the user. That means I can use a 0 to 5 volt serial connection, and it also means I've been able to alter the baud rate because I've also connected to the transmit and receive clock pins, so I'm actually running at 2400 baud. We may have a look at that in a later video, but that's why things go a little bit quicker than you think they might do. Right, the first thing to do, let me just show you what happens here. If we do a display memory, which is D, I'll just do a few bytes. There we go. Now you sort of think nothing had happened, but what's actually happened, if we go back to the teletype terminal, it's actually displayed it there, and that's because we haven't assigned the console list device. We do that by doing a list, which we just abbreviate with LI, equals CRT. And if I do the same command again, D0F, now it comes out on the right screen. So that's just something to watch. To test the actual interrupts are actually working, I've created a little program. If I go along to here, right, here we go. The 8080 has got 8 interrupts separated by 8 bytes. RST0 right up to RST7, which is down the bottom here. Oh, hang on, it slipped off the bottom of the screen, hang on. There we go. There he is. Right, okay. So what I've done, it's fairly crude. I've put the ASCII value of the number 1 in register A. I've then output that to the CRT USART data port, which is F6 hex. So effectively that will print a 1 on the screen every time we get a interrupt 1, and that's repeated all the way down. At the end of that it just jumps to start. So if we scroll down again, it just jumps to this program here, and this is the sort of crux of the program here. It does a disable interrupt. It puts 12 in the accumulator, outputs it to FD hex, which is the interrupt controller. That just configures the interrupt controller to work as we want it. I then put a 0 in the accumulator, and then output that to FC hex. Now that effectively unmasks all the interrupts. If I was to put FF in there, all of the interrupts will be masked. That is, you know, when you pressed one of the switches, nothing had happened, and they're just in order. So you know, this will be 1, 2, that'll be 4 in binary, obviously 8. So you know, you can mask them out individually if you wish. Once it's done that, it does enable interrupt, and it jumps back to loop. So it'll just be, oh sorry, it'll just jump to there and go around in a circle while we're waiting for one of these switches to be pressed. Right, okay, so I could obviously put this all in by hand, but that would be rather tedious. Luckily the monitor can read hex files, so that's what we'll try. We'll get it ready by typing R0, and that means read hex with an offset of 0. And then in the other terminal we need to get ready to send that file. So we'll go to File, Send File, and then scroll down to the program. There it is, interrupt.hex. There we go. Well, what I'll do, I'll hover over that open. The problem with doing it like this is that it expects what we're using here is effectively the tape reader on the teletype, and it expects that tape reader to be running before you hit return on the R0. So what I've done is the front of this file I've packed with loads of nulls, and in that way I can hit return on this screen, then flip over to the other one and then hit return on the R0. Otherwise there's no way I could do it quick enough. Here we go then, return over there. Right, that should load our program. Now if we do display 2000, let's go 20 FF, we don't really need that much. Right, we should see our program here. So we've got F3, 3E0C. If we look at our program listing, we should see the same thing. There we go, F3, 3E0C. Right, so we should be ready to run the program now. So what I'll do go 2000. Right, program's running now. So if I press one of the interrupt switches, we'll start with number 7. There you go. So that's generated an interrupt. The number 7's come up on the screen. I press 6. 6 comes up. 5 comes up. 4, 3, 2, 1. Right, so they're all working and they're all generating interrupts. Obviously the interrupts ignoring so quickly we haven't actually seen the LED come on. Interrupt 0 is defined in the monitor as returning back to the monitor. That's how you get back when something goes wrong. So if I press 0 now, we should return to the monitor. There we go. Right, so that's the demonstration of the front panel. Right, as a final test today, I've installed the other 16K RAM board, so we'll do a quick test on that. What I'm going to do, I'm going to use the ported Altair monitor I showed in the previous video. I've moved it though down to 3800 hex. So what we'll do the same thing again. We'll get the MDS ready to receive the file. We'll flip to the other teletype terminal and we'll get ready to send. Let's just scroll down. We're looking for this one here. I'll just hover over that one. Get ready to swap over quickly. Right, this will take a little bit longer to load, obviously, because it's a much bigger program. Looks like it's loading. Right, prompts come back. I'll just do a quick display memory, make sure it has actually come out. Right, I can see the start of the monitor there. I recognise those 2 bytes. So I'll start the monitor. Here we go. You'll probably recognise that from the previous video, and obviously if you watched any of my Altair videos. To test memory, it's all built into this monitor, which is why I'm going to use it, and it's very simple. You just type T, the start of the memory. In this case it starts at 4000 hex and it runs to 7 FFF hex. Right, and away it goes. The little periods that are appearing here, that signifies one loop of the test and it's succeeded. So that all seems to be okay. Right, so that'll do it for this one, and I shall see you next time.